Okay, so we are starting on a new unit today. Okay, we're going to be on Unit 10. We are skipping Unit 9. We will come back to it, but because of the way spring break falls this year, we're going to move to Unit 10. Okay, it's a little bit shorter, I think, than 9. So this unit is all about probability and statistics, okay? This is a very small sampling of what you would take if you take probability and statistics next year, okay? This is a very, micro, small amount of what you would do in there. Okay, so first thing we're going to start with is something called the fundamental counting principle. And it's principle like a rule, not like the leader of the school. Okay, fundamental counting principle, and we're going to work on something called permutations today.
Ooh, see, when you play mallet, those things are like ridiculous. Lateral permutations are the worst.
So, great. Okay, the fundamental counting principle, I'm just going to abbreviate it as FCP, okay? Fundamental counting principle, means you take, permutations, PERMUTATIONS. FCP, fundamental counting principle. I was just abbreviating. Fundamental counting principle means you take number of choices, take the number of choices in each category, and multiply. Okay, so you take the number of choices in each category and you multiply them together. Okay, so there are 13 examples today. I know that sounds like a lot. This first page is going to be a lot of writing. Okay, after that we're going to move to something different. So just understand this first page is going to be a decent amount of writing. Okay, so for example, number 1, if I tell you an ice cream store has 42 flavors of ice cream, 8 toppings, 8 toppings, and 2 syrups. You will be glad that this is the amount of things they have in just a minute. Okay, I want to know how many different sundaes. Notice that is not spelled like the day of the week Sunday.
How come that 42 flavors but only 8 toppings?
They're limited budget. Okay. How many different sundaes are possible? They make their own, using one of each.
How do you even make 42?
Okay, so I want to know how many different sundaes could they make if the only thing you can order at this place is a sundae, and it comes with 1 flavor of ice cream, 1 topping, 1 syrup. Okay, the way that you do that is I'm going to encourage you to literally write spaces. Okay, so you're going to put a space and fill in the amount of flavors. So how many flavors are there? 42. By that, you are going to multiply by the number of toppings. And yes, I'm labeling this first example, but you're not going to have to write the labels underneath for all of these. Multiplied, so 42 flavors multiplied by 8 different toppings, multiplied by the number of syrups. And there are 2. Literally, to find out the number of combinations or the number of possibilities, you just multiply them together, okay? For this unit, this is one of the only units in Algebra 2 that we allow you to use calculators, okay? That does not mean phone calculators, by the way. Okay, so if you have a calculator at home or in your backpack, whatever, please bring it. You will want to use it. Okay, if you would like to borrow one, I have a bunch of them up front. If you want to borrow them, you just need to leave me your cell phone, because then I know you will give it back. Okay, so you have to leave something for me, and you can borrow my calculator.
That's very smart. So
I try.
Condo makes
Thanks.
us give our IDs, but
Right, but you guys don't really care about your IDs,
well,
so.
except for like unless we want.
Okay, well, anyways, you want my calculator, you give me your cell phone in trade. Okay, if you're afraid someone might steal your cell phone, you can give it to me personally and I will keep it in my pocket. Okay? Is this going to be an appropriate question? Ben? I know. I can't understand you. Okay, so here, multiply together, 672. That's your answer. Okay, that's it. So we're just going to be multiplying.
All that just to multiply.
Yep, just all that just to multiply. Okay, using the symbols. Using the symbols. Star, less than, greater than, at, pound, and percent. Using these symbols. How many different four-symbol passwords are possible? So, again, I would encourage you to write the number of spaces, so I would write out the spaces. So we're going to make a four-symbol password, okay, like a computer password, but you can only use these symbols. So, how many do you have to choose from for the first one?
3.
Okay. These are the ones we get to choose from. How many do you have to choose from for your first symbol?
6.
6. Multiplied by, how many do you have to choose from for your second part? 6. Times 6 times 6. You have 6 to choose from in each space. Okay? This is not 4 multiplying. You have 6 choices. So you write your number of choices multiplied by the number of choices and keep multiplying. Okay? If you multiply these all together, we got 1,296. 1,296.
Okay, but in what world would somebody want to know how many different like possible combinations they could have?
Well, you need to know, like, let's say,
Hold on. What if you want to have a phone and you're like, okay.
exactly, right. Or, this isn't, okay, yes, there is definitely
Yes.
a,
You have
yes,
to try.
if you're a hacker, this is helpful to you. Or say, if you're a bank, okay, say, I need to make a PIN number or something, and you want to figure out, well, how many digits does it really need to be? Like, if you only had 2 digits, there's not that many, so people could easily hack into it. So it's to figure out, like, how many possibilities do you need?
Could I
Okay.
use it to hack into the bank?
You could try, sure.
Okay, so
Go for it.
I'm gonna become a bank
No.
hacker.
For example number 3, how many different 7-symbol license plates can be made if the first 3 must be letters, so if the first 3 parts in the license plate are letters and the last 4 digits. So this is actually something that the state of California kind of had to figure out. Like, okay, or any state for that matter, how long does our license plate need to be? Okay, they had to figure out, okay, how many people are there, and they had to figure out how many do I need it to be? Do I need it to be numbers? Do I need it to be letters? Can it be a combination of both? Okay, I fully understand that in the state of California, we do not have 3 letters and then 4 digits. Okay, but this is just an example of that. So if the first 3 have to be letters, and the last 4 have to be digits. How many different options do you have for the first space?
26.
26. Heads up, there are 26 different letters in the English language. No, we do not get to use E with the thingy on top of it like in Spanish. Thank you. Whatever. So, 26. I don't know what you call that above the E. The accent mark. Okay? How many different possibilities are there for the second space? 26. How many for the third space? 26. How many for the fourth space?
10.
How many digits are there?
0, 1, 2.
Let's think about this, okay? Because a ton of you guys think 9. Count on your fingers. Look. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. There are 10, okay? Heads up, the number 10 is not a digit, okay? It's a number, but 0 is a digit, okay? So 0 through 9 are digits. There are a total of 10 of them, okay? 10 different digits possible. Multiplied by another 10, and another 10. So if license plates were strictly made out of 3 letters and then 4 digits, okay, 3 letters, 4 digits, you would have a total possible of 175,760,000 combinations. Okay, this is kind of like why everyone in the United States can have a social security number and it's a different one, because the number of possibilities are so high.
Wait, you can have letters in your social security?
No, I'm saying digits,
okay,
yeah.
Okay.
That's why they're so long, so that everyone has a unique one. Okay? Now, number 4, we're almost done with these word ones. Okay? Using the same parameters, so that means same rules. Okay? Using same parameters as number 3. Using same parameters as number 3. Find the number possible if no repeats are allowed. Find the number possible if no repeats are allowed. So again, we're going to start with the first 3 being letters, the last 4 being digits. So for the first space, how many do you have to choose from? 26. For the second space, how many do you have to choose from? 25. So no repeats, meaning you couldn't have like A and then another A. Okay, once you've used a letter, it's no longer possible, so there'd be 25. Then your next space, you'd have 24 possibilities. How many for this space? 10. Okay, we're back to digits. So 10, then what? 9, then 8, then 7. Okay, if you multiply all of those together, even with no repeats, you would still have a number of possibilities of 78,624,000 possibilities. Questions on how we did that? Not too bad, right? So literally, fundamental counting principle means write out the number of spaces, write in your possibilities, multiply together. That's it. Okay? I make it as simple as possible. Write out the number of possibilities, multiply together. That's it. Okay? Next thing we're going to go over is something called factorial. Okay? Something called factorial. It is not factoring, so don't worry about that. Okay? Factorial. Factorial is denoted by an exclamation point. Okay, so if I ask you to find, the way you say this is if I ask you for 3 factorial, it's 3 exclamation point. What factorial means is you literally multiply this whole number with every whole number below it until you get to 1. So 3 factorial is really 3 times 2 times 1. What is 3 times 2 times 1?
6. But,
6.
So you include the number that it is?
You include yes, this is your starting number, and you go all the way down to 1, and we're only multiplying by whole numbers. Yes.
Were you going to have some ridiculous number like 52?
You're not going to have 52, but you are going to get a little larger numbers. Okay? Something like number 6. Try 7 factorial.
You know, like sometimes you take like 2 numbers in factorial, you multiply them?
Yes. So 7 factorial would be 7 times 6 times 5, 4, 3, 2, and 1. If you multiply all of those together, you get 5,040. Now, there is a much simpler way to do factorial, though, than to actually write all these out. Okay? If you have a calculator, this is the most common type of calculator that people have, so I'm going to show you on here. Okay? The way you do this is you put in your first number, so like I'm going to just show you 7 factorial. Then you look under the button that says PRB, that stands for probability. So PRB, there's going to be 3 things here. There's something that says NPR, we're going to get to that. and CR is what we're going to do on Monday, and then the exclamation point, okay? So you just scroll over to the exclamation point, hit enter, then you have 7 factorial on there, hit enter again, and it gives you your answer, okay? So calculators are your friend for this unit. You just have to, and if you don't know how to use your calculator, figure it out, okay? Because I'm not going to answer a million questions about how do I do this on a calculator the day of your test or the day of a quiz. That's also the same reason I don't want you to use your phones, because if you only know how to use your phone calculator, I'm not letting you use it in class. So figure out a calculator. Yes?
Can we use calculators on our test?
Yes, you will be able to use calculators on your test, as long as it's not the one on your phone.
Okay.
Okay, something like number 7. Now let's try 6 factorial divided by 4 factorial. 6 factorial divided by 4 factorial. Couple different ways you could do this. You could figure out 6 factorial on your calculator, and that's totally a viable option. Then find out 4 factorial on your calculator and divide. I'm going to show you an actually easier way to do this. The easiest way to do this is 6 factorial is really what numbers multiplied together? 6 times 5 times 4, 3, 2, 1. Divided by 4 factorial is 4 times 3 times 2 times 1. What do you know this is going to happen here? These go away. So really, 6 factorial divided by 4 factorial is just 6 times 5, which is 30. That's your answer. So you want to try to cancel out or reduce as much as you can, okay? Not because you can't do it on a calculator, but a lot of times people just make a lot of mistakes when they're punching things in. And I want you to understand, if you don't have a calculator, how you could still get the same answer. Okay, try another one. Number 8. Almost done, guys. 9 factorial divided by 3 factorial, 5 factorial. 9 factorial divided by 3 factorial, 5 factorial. Now, when you have 2 on the bottom, you are going to multiply all of those together. So this is going to be 9, 8, 7, 6. Would you agree that 5 and everything below it is going to cancel out with this 5 factorial? Right. So I'm not going to write those. I'm just going to write 5 and an arrow for everything below it, because I know it's going to go away, so why bother writing it? Over 3 factorial is 3 times 2 times 1, multiplied by 5 and everything below it. Again, I'm not going to write it all out, because I know it's just going to cancel away. So these will cancel, those will cancel. Is there anything else that can cancel? Anything else reduced? 3 and 2 cancel out all of 6. Or you're right, you could reduce 9 and 3. Okay. However you do this, do the multiplication, and you should get 504. So 9 times 8 times 7 is equal to 504. That's your answer. Anyone have questions about factorial? Oh, good. Okay. Next thing we're going to go over is spelling. Okay. No, we are not really going to be testing your spelling, but I labeled this spelling because, well, that's kind of what it involves. So for number 9, I would like you to find all possible arrangements of the letters C, A, T. Find all the different arrangements of the letters C, A, T. So start naming them off. Obviously, C, A, T is one of them. How else could you arrange those? ACT, TAC. They don't have to spell anything. CTA. Not ABC. Any other ways that you could arrange those letters? TCA. ATC. Can anyone think of any other ways to arrange those? Okay, so we have 6. Awesome. But I'm going to tell you, this is not exactly the most efficient way to do this. Okay? There is actually a rule here, And the rule for finding all the possible arrangements with spelling or with letters is you take the total number of letters, factorial. Okay, so take the total number of letters, factorial. So this would be what? How many total letters do you have? 3 factorial, which is the same as 3 times 2 times 1, and that multiplies to 6. Okay, so to get this, you could either do factorial, or actually, you could do the spaces. Okay, if you have 3 letters, say, in a hat, you pull one out, you have 3 to choose from. Then if one's gone, you have 2 to choose from. If one's gone, you have 1 to choose from. So there's a couple different ways that you could get the right answer here. Okay, but in any case, it's 6. Questions on how I did that? No? Okay. Number 10. For this one, I want to know how many distinguishable permutations are there of the letters J, U, S, T, I, C, and E. Now, the reason I ask you distinguishable permutations is that's how math likes to ask you, okay? And all that basically means is how many different ways could you arrange all of these different letters? Now, you probably don't want to write out every single different way. It will take a long time. You will probably miss some, okay? So you want to use the formula here. So really, you figure out how many total letters are there? 7 factorial. Okay, 7 factorial. Or you could do the spaces, 7 spaces. And you'd multiply 7 times 6, 5 choices, 4, 3, 2, and 1. And if you multiply all those together, 5,040. So there are literally 5,040 different ways that you could arrange those letters.
Yeah, so that would have taken a very long time.
That would have taken a very long time, yes.
Probably
And
taken
too much paper.
5,040 years.
Well, hopefully not that long. Okay, next thing we're going to go over. So anyone have questions about spelling? Distinguishable permutations. Next thing is going to be spelling, again. But this time with repetition. Okay, spelling with repetition. So for example number 11, I want you to find the number of distinguishable permutations. So that basically just means different arrangements. Okay, permutations are arrangements. Distinguishable means different. So the total number of distinguishable permutations in the letter with the letters C, O, O, and N. How many different ways can you arrange the letters in my last name? Too many. Well, that's a good guess, but I'm looking for a number here. Let's write them out. So obviously we could do C-O-O-N. How else?
O-O-N-C.
O-O-N-C. How else? N-O-O-C. O-O-C-N. O-C-O-N. O-N-O-C. Come on, you can figure this out. You guys are not good at this game.
C-N-O-O.
C-N-O-O.
C-O-N-O.
I was like, that was a lot of N's and O's. C-O-N-O.
What's up, Colo? N-O-C-O.
How many more are there?
N-O-C-O. There's a lot, actually.
No, I meant like how many more examples?
Oh. N-C-O-O. 13 total. You think that's it? Any others?
No. Isn't it called repetition because it's like 2 letters?
Right, because there's 2 letters that repeat.
So isn't it tune again?
Well, because like if
No, so distinguishable permutations means different arrangements of the letters. Right, because otherwise you could say like, oh, the first O and the first and then the second O. Yeah, that doesn't work. Okay, I'm going to challenge you that there is also ONCO, and we're missing one. OC and O. So, how many total are there? Count them.
12.
There are 12, okay? Because I want to know that you can count, okay? Now, this is obviously not a very efficient way of figuring these things out. So, with repetition, there is a formula you want to memorize, okay? Repetition, you take the total number of letters, factorial, total number of letters, factorial, divided by each repeat, factorial. Okay, each repeat factorial. If you use the ones without repetition, this would be 4 factorial. I know, and you will remember eventually, that 4 factorial is 24. There's obviously not 24 of these. So, you take the total number of letters, which in this case is 4 factorial, divided by each repeat. In this case, there are 2 repeats. And then you divide. So this would be 4, 3, 2, and 1, divided by 2 times 1. The 2 and 1 reduce. 4 times 3 equals 12. Okay? This is a formula you need to memorize. Okay, you need to. Same thing, I want to know how many distinguishable permutations there are in the letters B, A, N, A, N, A. How many different ways? Did you just say this? How many different ways can you arrange the letters in banana? 13 total. We might be able to. So, the way you have to do this is total number of letters. How many letters are there total? 6 factorial. Divided by each repeat, okay? How many A's are there? 3 A's. And how many N's are there? 2. Okay? You do each repeat separately. You do not combine these together and say that this is 5 factorial. Okay? That is totally different. So when you work this out, we have 6, 5, 4, 3, 2, 1, divided by 3, 2, 1, multiplied by another 2 and 1. Cancel out what you can. And this will give you 6 times 5 times 2 is equal to 60. Okay, make sure you look on the website for this last one because it's kind of important. Okay, then last thing we're going to do is I'm going to ask you to find the number of permutations. Okay, and I'm going to give you a formula. There's a formula for permutations by definition. Okay, by definition, permutations are NPR. Okay, and NPR is equal to n factorial divided by the difference n minus r factorial. Okay, we are not necessarily using this formula today, but we will be. Okay, so if for number 13, and this is the last one, I ask you to find 7p5. What you have to know how to do is plug into this, okay? So here, you always do the left number, the number on the left, factorial. So what's the left number? 7 factorial. Divided by the difference, left minus right, factorial. So 7 minus 5 factorial. So if we work this out, this is really 7 factorial over 2 factorial. Then you multiply 7 every whole number below it till you get to 1 over 2 and 1. And if you multiply all those numbers together, you get 2,520. Questions on how I did that? Now, I'm going to tell you there's a lot easier way to do that though. Okay? Let me show you this because you're going to want this shortcut. You have a bunch of these on your homework this weekend. Shortcut is calculator. Okay, let me show you on the calculator how to do this. You plug in the first number. So in this case, it was 7. So we do 7. PRB for probability. Okay? There's a button that says NPR. Scroll to it. Don't use NCR. We're going to do that later. So NPR. So 7, NPR. Second number, 5. Enter. There's your answer.
Do you
Okay.
have homework packets?
Yes. You do have 2 things for homework. One is in a packet.